Today, let's talk about this specific issue. It's a common problem with Apple's A16 CPU, specifically related to the barometer. This part is prone to open circuits. Once there's an open circuit, it will cause the device to restart every 3 minutes. Normally, if we use this feather blade to scrape, it's actually not easy to scrape effectively with this kind. We need to use this type. These are very cheap blades, and they're very sharp. It's the Miss Sun brand blade. Let's take a look at how to fix this 3-minute restart issue. We need to find the corresponding contact point below. It's right here. This blade is already broken. The sharp tip at the front accidentally broke off, so it can't be used anymore. But this one's tip hasn't broken. Let's locate this contact point. We don't have to use a high-quality blade. In fact, good blades are not as easy to scrape with as this one. Okay, when scraping, there's a problem now. We accidentally touched that upper contact point. If we touch it, then when we adjust the direction to work, if we still touch it, it will cause a short circuit when soldering the solder ball. Now, this contact point has been fully exposed, and it's the entire contact point with no copper exposed around the edges. So the wire bonding process will be very simple. When doing the wire bonding, we first solder a single solder ball on it, just one. The best method is to solder the ball first, and then perform the wire bonding afterwards. That's the optimal approach. Good. Now we can clearly see that the solder has perfectly bonded with the exposed contact point on the CPU. It's a perfect bond. Then we clean it up. After cleaning, take out our wire. As for the wire requirements, basically, if there are no scratches or adhesions around the area, the required wire diameter can be slightly smaller. Pure red wire is easier to solder, but it's susceptible to oxidation. No other issues though. This wire will be relatively long, and since we need to cover a large span, if the span is large, what's the difficulty here? The difficulty is that the wire will flop around easily, because we need to connect this contact point to that one. So the wire span is quite large. That's why when we use the heat gun, the wire tends to blow around easily. So we need to control it properly now. Align the end of the wire with the solder ball we prepared earlier. A quick blast with the heat gun, and it's attached. Let's do it. This time, the wire isn't twisted. It's better if the wire isn't twisted. Just a little soldering is enough. The best method here is to apply some flux here first to fix it in place. Then we can clean it separately later. When applying the flux, we can do additional cleaning afterwards. This way, we won't have the problem of the wire being blown away like before. Okay, let's zoom in further. When doing this wire bonding, you must be steady and take it slow. Good, it's attached. Now that it's attached, we can clearly see the solder ball we placed earlier. It directly wraps around this wire. Now let's clean it. Be gentle when cleaning. Move along the direction of the wire. The wire also needs to be straightened out. So when cleaning, we clean in this direction. Keep cleaning. This wire is extremely thin. It's the thinnest type you can buy on the market right now. This is the exact wire. In this current state, we can see that this wire is even thinner than the original thin circuit traces on the CPU. Good. We can't turn on the UV curing lamp yet. If we do, it will harden too much later, which will affect the solder ball placement. First, we spread the flux evenly to other areas, and if you don't want it to bulge up, just press it down with a solder mask stencil. Once pressed with the solder mask stencil, it will be fine. Turn on the lamp. Keep pressing. This method ensures the entire wire is tightly attached to the CPU and the entire surface remains perfectly flat. It won't affect the solder ball placement. It also prevents the problem where bulging areas might cause unevenly sized solder balls later. Now we need to test it. Why do we need to test? In case we accidentally caused a short circuit while scraping the contact point earlier, this area could be shorted. But currently, the resistance shows infinity, so we still need to test first. This saves us from unnecessary troubles later. 1, 2, 3, 4, 5. This is the barometer circuit. Good, it shows OL, open line. Let's test this wire. Okay. So now this wire has a normal resistance reading. If you find it difficult to handle the wire during this process, you can do it like this. Like I'm doing now. First, move the wire to the pad position. This makes it much easier. After that, you just need to use the heat gun. Try not to use a soldering station for wire bonding on this CPU. If you use a soldering station for this, a slight hand tremor could easily puncture the CPU with the soldering iron tip. Now that the wire has reached this state, the wire bonding is complete. Once we reassemble the device, it will fix the issue where the barometer isn't detected, as well as the minute restart problem. Clean it thoroughly. Be gentle when trimming. Using second curing flux gives the strongest hold. After that, no matter how you clean it or place the solder balls, this wire won't get damaged. No breaks, no damage, no cold solder joints. Perfect. Good. Earlier there was a small exposed part of the wire here. Now this wire repair is complete. There's one more thing. We can clearly see that the flux here is higher than the flux over there. When placing solder balls, the solder balls in this area might end up slightly too big. So again, take the solder mask stencil and place it on top. Go. Press down. Turn on the lamp. Done. Then, since we used the pressing method, a little flux might seep out. At this point, we can take a blade for final trimming. And with that, the repair is fully complete. Just be bold, it won't cause any problems. At the end of the video, we'll include the restart code. Bye, see you.